Excellent. So yeah, welcome to our I think it's the penultimate lecture this term. So we have Marie at the end of term, but we're delighted to welcome back Dr. Simon Cotton back to the university as well. So he and I have been here for a while lecturing, and Dr. Cotton is talking that very topical talk on drugs in sport, and just a few other people that I'm omitting. So in a minute, I'm going to share the screen and hand over to Dr. Cotton. So thank you all for joining us once again. As usual, if you have questions, if you could put them in the chat box, and then we'll address those at the end.
Good evening, everyone. Welcome to the University of Birmingham. Talk tonight about drugs in sport. What I'll try and do is to introduce you to a variety of molecules, mainly small molecules. They'll look a bit odd to you, especially if you're year 12, but many of them contain functional groups that you'll meet with in the course of A-level chemistry. And I'll try and point out how to recognize those. Okay, let's start with amphetamines. Now, they've got quite a history. They started being used, especially during the Second World War, to help counter fatigue, watchkeepers on ships, people like that. And then they were taken up in the post-war world and started being used as performance enhancers in the 1960s, really. Now, on the screen are 4 related molecules. Phenylethylamine, that's a primary amine, it contains an NH2 group. That's actually found in a number of places in nature. It's in chocolate. It's supposed to be made in our brains when we fall in love. But you can't fall in love by eating chocolate because our bodies break it down. Now, that's natural. But the amphetamines, like amphetamine itself and the methamphetamine, those are pretty well synthetic. They are man-made, and because they haven't quite got the same structure as phenylethylamine, the human body doesn't really know what to do with it. And that causes some of the problems. Now, of course, many people, when you mention methamphetamine, think of this famous TV series. Well, there you are. But where does it fit in sport? Well, probably the most famous sportsman who took methamphetamine and was victim of it was Tom Simpson. He was a very famous British cyclist. People don't know about him now. But if I tell you that he was the BBC Sportsman of the year before Bobby Moore, the England World Cup winning captain, that will give you an idea of how important he was in sport at its time. He was a world champion. He was the first British cyclist to wear the yellow jersey in the Tour de France. In 1967, he was a victim of amphetamines. The picture on the screen now shows him on the climb of Mont Ventoux, which is a very famous mountain climb that's on the tour many years. He took amphetamines, and on this baking hot day, he paid the penalty. The amphetamines meant he went through the red lines. He died of heart failure. That picture was actually taken of him about half an hour before he died. This is Mont Ventoux. He died on a baking hot August day when, in addition to everything else, all that heat was being reflected off the limestone, and the temperature there was probably maybe in the 120s, even higher. And imagine going full out on a bike, hill climbing. And just below the summit, there's a monument to him. I've been up there, I've photographed it, and even on dull days, people all over the world come to visit that monument. Anyway, methamphetamine isn't the only stimulant. Here's another case of this. This is very recent. A couple of top 100-meter sprinters, Tyson Gay and Natasha Powell, they tested positive for this molecule, oxyphene. And again, you can see the key structure, the benzene ring, 2 carbons, and an amine group. This is actually a secondary amine because one of the hydrogens has been replaced by a methyl group. But it's still an amine, and it acts as a stimulant in a similar way to methamphetamine. It has similar properties. It enhances your blood flow, it pushes up the heart rate, and these sportsmen claimed that they'd taken it unknowingly. But the World Anti-Doping Agency regulations say that if it's in your body, you are liable. And so whether or not you were aware of it, you pay the penalty, so that Gay lost an Olympic medal. He's not the only person that's affected, as we'll see. Here's another victim, an American baseball pitcher. He died through taking ephedrine. And again, you can see the core of the molecule, the benzene ring, 2 carbon atom side chain, and then the amine group. And again, it's a secondary amine because it's got 1 hydrogen in the amine group replaced by methyl. An Australian jockey. She was found to have taken phentermine. Again, you can see the core of the structure, benzene ring, 2 carbon side chain. There's your primary amine group, and there are 2 methyl side chains there. So again, that's thought to be a stimulant too. Other amines are stimulants, whether or not they have got the benzene ring in them. Here's methylhexanamine. You can see it's got the 6 carbons side chain. Here's the longest chain, 1, 2, 3, 4, 5, 6 carbons, and it's got a primary amine group. And we'll see why it's called duranamine in a moment. It's a stimulant. It was originally introduced as a nasal decongestant in medicine, and then people found these side effects. And so it got withdrawn for everyday use, but hey, there's a black market. And here we've got a German Winter Olympic, shows a skier here who tested positive 2 Winter Olympics ago. Why is it called duranamine? Well, some people claimed that it could be found in geraniums, and so it was a natural substance they were taking. Well, that's controversial, but it's banned. It's prohibited by the World Anti-Doping Agency. But a close relative of it, dimethylbutyramine, shown here, very similar structure. You can imagine it fitting in the same bodily receptors. That started appearing in sports supplements, and that has never been tested on humans. People are taking these substances and they don't know what they may be doing to their bodies. Back with duranamine, 2 Olympics ago, one of the Jamaican 4x100 relay team tested positive. Here they are, they've won the gold. Test turned positive. All 4 of them lose their golds because one of them had been doping. And that's how Usain Bolt lost one of his 9 gold medals, because one of his teammates was taking a stimulant. Not just athletes, Dylan White, the boxer. he had a doping ban again for taking the stimulant. So it's very, very widely spread. Okay, we move on to EPO. Now, don't worry, you are not going to be expected to draw the structure of EPO in your A-level exams, but I'm mentioning it because it has been abused by a lot of people. This shows it. It's made of lots and lots of amino acids joined together. Each one of these black blobs is an amino acid. The best diagram I could find is a German one. And if you speak German, you'll recognize that aminosäure means amino acid. And so it's got this polypeptide type chain, lots and lots and lots of amino acids joined together. There are some disulfide bridges there and there. And you've got a few sugars added on and all sorts of things, but basically it's a polypeptide. Now, EPO is found in our bodies naturally. It acts as a hormone. The body makes it in the bone marrow to help us make red blood cells, because without red blood cells, living's in vain. That's a very bad joke. I don't expect you to laugh. And you can enhance your EPO levels and hence your quantity of red blood cells by altitude training, because people who live at high altitudes where the levels of oxygen are lower, their bodies compensate by speeding up their EPO synthesis to make more red blood cells to help them carry oxygen. But you can also make synthetic EPO, known as recombinant EPO, and that's different structurally to normal EPO in the sugars attached to, in the side chains, and you can detect that by testing. Well, before the testing came about, maybe about 20 years ago, quite a lot of people abused it. It was particularly the case in cyclists. You can measure the percentage of the blood that's red blood cells. And if you're a top athlete, this comes out, it's known as your hemocrit level at 40–45%. But a lot of these cyclists in the 1990s had rather high levels, 50–60%. Bjarne Riis, who's still active in cycling, he won the Tour de France once. He was known as Mr. 60%. There's a problem with that, because the higher your EPO level, the thicker, the more viscous your blood is. That's fine while you're pumping around, riding your race. But when you shut off, especially when you go to sleep, your blood churns around more slowly. And back in the past, in the 80s and 90s, a lot of pro cyclists, you're talking well over 20, actually died in their sleep, almost certainly killed by their high levels of EPO. People are still taking it. This athlete, Eric Schwarzer, he took EPO. He'd won the gold in 50-kilometer walk at Beijing. 4 years later, in the London Olympics, he tested positive for EPO. They found he'd got the synthetic version in his body. There's no chance that was there naturally. So he was disqualified. I think he may have kept his medal from Beijing. That raises questions, doesn't it? Here's someone who famously took EPO, Marco Pantani. He was a top European cyclist of his day, a very famous Italian cyclist. This is him in the 1997 Tour de France. He didn't win it. He was up against Lance Armstrong. Sadly, sorry, he did win in 97. Armstrong won in 98, my mistake. Sadly, it was soon possible to detect EPO. He was disqualified from the 1999 Giro, which is one of the other two big cycling tours, along with the one in Spain. And suddenly his career went down and he died in 2004 from a huge cocaine overdose, lonely by himself in a hotel room. Now, of course, the most famous cyclist who abused drugs was Lance Armstrong. There are two very good books about Lance Armstrong written by David Walsh. David Walsh is a very fine sporting journalist. He writes for the Times and the Sunday Times. You can still read his column there. He was convinced that Armstrong was abusing drugs long before Armstrong was caught. And he said so in print. Armstrong won several Tours de France in succession. It was quite remarkable because in the mid-1990s, he had testicular cancer. And he was put on a cocktail of drugs, one of which was a platinum compound called cisplatin. And you'll almost certainly hear about that in your A-level chemistry course. It was discovered by accident in the 1960s by a bunch of inorganic chemists that this molecule could cure certain tumors. It was taken up, it became a drug used to treat certain cancers, especially testicular cancer in the early 1980s, and it's still in use along with some others that are improvements on it. Lance Armstrong took it, it cured his cancer, it saved his life. You'd think that after that, someone might be careful about what they put in their bodies. Lance Armstrong took virtually every drug that was on the market. Amphetamines, EPO, testosterone, which we'll come to later, human growth hormone. Scary. Next, let's have a look at what some steroids are. They're not so much in fashion now, but they were big from the 1950s onwards. Steroids like testosterone were first identified and isolated in the 1930s. And they started being used in the late 1940s and 50s, and the use spread. There were three key periods for their abuse, especially in the 1970s and 80s. East German athletes and swimmers were made to take them, especially female athletes and swimmers. More about that in a moment. Then sprinters would take them, and more recently, again, athletes and baseball players took synthetic steroids, so-called designer steroids. We'll see a bit about all of these. Now, you may say, what's a steroid? This is not a steroid, this is an asteroid. This is a very, very, very big molecule. You could not get this in your body. How do you recognize a steroid if it comes up to you in the street and says, hello, I'm a steroid? You look at its structure. It's got 4 rings fused together, 3 hexagonal rings, and then a 5-membered ring attached. All steroids have got that core system. Other groups are attached. Here's testosterone. This is probably the best known steroid. It's the male sex hormone. It's not just men who've got it. Women make it too, but in small amounts. Now, maybe a particular woman has got more than a particular man, but on average, a man has got more than a woman. It's what's called an anabolic steroid. That means it enhances muscle mass and strength. But the body also uses it to make other steroids in the body. So it's a natural steroid. But of course, people can abuse it by taking more, and they do, by injection. Now, if you look at the structure, there's a carbonyl group here. It's a carbonyl group attached to a ring. It's in mid-chain. That makes it a ketone. And that's how it's got the name testosterone. It's an one. But on the other side, you'll see this OH group. That's an alcohol group. And you can do chemical reactions with alcohols, as some of you will know. And one of the things you can do is to replace the hydrogen with what's called an acyl group. And that makes what we call an ester. And these esters aren't so water soluble. They haven't got an OH group. They're more lipid soluble. And they can be absorbed through the skin. So people sometimes taking testosterone esters will take them via skin patches. But you can take some of them via the mouth as well. Well, what happens to testosterone in the body, if it's not being used to make other things or to have anabolic effects, the body oxidizes it, and that oxidizes it to something with two carbonyl groups. I beg your pardon. I'll say it again, two carbonyl groups, there and there. And that makes it a dione. It's got two carbonyl groups. This is androstenedione. Now, a reminder about oxidation of alcohols, which some of you will be experts on. If you're primary alcohol, your OH group's at the end of a chain. Secondary alcohols, the OH is in mid-chain. Like that, it's still to hydrogen opposite. If you're tertiary alcohol, the OH group's at a branch in the chain. So that carbon, the OH, is actually got no hydrogens. A primary alcohol can be oxidized by pulling off one of those H's and the H off the OH group to create the carbonyl group. That makes an aldehyde. Oxidizing primary alcohols makes aldehydes. If you're a secondary alcohol, you can take the H off the OH and the H off the carbon. That generates a carbonyl group. In mid-chain, it's a ketone. That's a ketone, people. That is not some sort of seagull. And finally, if you get to a tertiary alcohol, there's no hydrogen attached to the carbon bearing the OH, so it is not easy to oxidize. No, you can't oxidize it. No way, Jose. You can hit it very hard with certain chemicals and start breaking carbon-carbon bonds. You can't easily oxidize it. Why am I telling you this? Well, apart from telling you something about oxidizing alcohols, which you need to know about for A-level, I'm also explaining why tertiary alcohols are very hard to oxidize. Now, some synthetic steroids have got an R group attached to carbon with the OH group. That makes them tertiary alcohols. That makes them very, very hard to oxidize. The body doesn't know what to do with them. They last long in the body. They've got big anabolic effects. There's a downside of that. Because they're so hard to oxidize in the body, they cause liver damage. And some people who've taken these synthetic tertiary alcohol steroids have suffered fatal liver damage. Here are two of the best known ones of sort. They're known as danabol and turinabol. They're originally made in 1960s medicines, but these were probably the two main synthetic steroids abused by East German athletes and swimmers. And I'm going to tell you a story about one of them. Rika Reinisch was made to take this by her swimming coach when she was 14. Why did these Germans have this program? It was before Germany was reunified. There was a West Germany, which was part of the free democratic West, along with France, Britain, Italy, Spain. East Germany was at that time a communist state, along with Poland, Czechoslovakia, Hungary, the USSR, and so on. East Germany's a small country. They wanted to get prestige, and they could do it through being successful in sport. And they targeted their athletes and swimmers, particularly their female swimmers. Rica Reinisch was told by a coach this would be good for her. She was already a top swimmer, made her better. The 1980 Moscow Olympics, she won 3 gold medals. She set 3 world records. She didn't test positive because a few weeks before, they stopped giving her the tablets, so her body would get rid of them. But of course, the body would still have the benefits of a couple of years of taking these steroids. 2 years later, she was at training camp. She collapsed. She'd been put back on steroids. She saw the doctor. The doctor said, "You must quit sport," at 16. Well, Rica Reinisch is still very much alive. She works as a sporting presenter. Now she knows what's happened because the truth came out after the Berlin Wall fell and Germany reunified. That's what she said on the screen. "I was lied to and deceived. Whenever I asked my coach what the tablets were, I was told they were vitamins and preparations. She's had health effects. Her heart isn't normal. She's had 2 stillbirths, but she can still smile." These Germans were very, very organized. The East German secret police, who were known as Stasi, kept records. These were found after unification in filing cabinets. They kept records. So you could see the records they kept for a long jumper to show how they're progressing, the distance they could jump, and also a decathlete, how the points they accumulated improved. So organized. If you want to read about this, there's a very good book. It's called Faust's Gold by Uncle Stephen Ungerleider. And that tells a story. And of course, the people behind it, like top politicians everywhere, all over the world, they got a slap on the wrist. They're not like other people. Okay, Ben Johnson. He was the top Canadian sprinter of his day, one of the very best in the world. He'd got a great rivalry with Carl Lewis, top American, and Linford Christie, British sprinter. This photo merits the term iconic. It's a much misused word, but this photo went round the world. This is Ben Johnson crossing the finishing line in the 100 meters in the 1988 Seoul Olympics. The 100 meters. Look how far he is in front of the competition. That is scary. Yeah, he's more than 6 feet in front. But 2 days later, they found metabolites of steroid in a urine sample. He was disqualified. He lost the gold. This is the front page of the Toronto Sun, top Canadian paper. Why, Ben? Well, here's stanozolol compared with methyl testosterone. That's testosterone with a methyl group replacing a hydrogen. And that's stanozolol, which is the same, but with an extra ring on the side. It's another tertiary alcohol. It's another of these illegal stimulants. How do they detect it? Well, the body tries to get rid of stanozolol. It's an unnatural molecule. It tries to get rid of it. How does it do it? Well, some enzymes stick in extra OH groups. There's one there, there's one there, and there's one there. They do that because when you stick in OH groups, you put in groups that can hydrogen bond to water. You're making something more water soluble. Remember hydrogen bonding? Yes, of course you do. And that helps the body get rid of it. And these molecules turn up in the urine, they can be detected, they can be separated out, and their mass spectrum identifies them. And people look at these rather complicated looking charts. This is normal urine on the left. That is urine with stanozolol metabolites in it. I beg your pardon. Notice a few differences. There's one little story in the background of Ben Johnson. Years later, his doctor and coach said, yeah, he was doping, but he wasn't taking stanozolol, he was taking flurazabol, which you can see is a rather similar molecule. And there have been suggestions, I don't know if they're true or not, that there were some people present in the room after the race where the urine samples were taken who shouldn't have been there, and they may just have slipped some stanozolol into Ben Johnson's urine. They weren't saying he wasn't guilty, but they were saying he wasn't taking stuff he was picked up for. Good story. Anyway, it's a book about this. It's called The Dirtiest Race in History. Came out about 7 or 8 years ago. I'm sure there are copies of that on Amazon and elsewhere on the internet. It tells the background of that race and the people in it. 6 of the 8 people in that race have tested positive for drugs and failed drug tests. It is scary. One of those was Linford Christie. 4 years later, he won the gold at Barcelona. He had a very successful career, but more or less when the career had ended, he was persuaded to come out of his retirement and compete. And hey, they did drug tests and they found breakdown products of nandrolone. Now, nandrolone is a very popular abuse steroid. This is nandrolone, and you can see it's actually a secondary alcohol. And it breaks down, it's broken down in the body. That carbon OH bond gets oxidized to a ketone, but this carbonyl group gets reduced. It's an unusual change, but you can recognize that stuff. Now, lots of people have taken it. Famous cricketer, Shoaib Akhtar, 15 years ago, one of the first 2 bowlers to go over 100 miles an hour. The other was Australian Brett Lee, if you want to use this as a quiz question. They called Shoaib Akhtar the Rawalpindi Rocket. I think the batsman in the picture is Ashley Giles, the former England spinner, now, of course, a coach and manager. Petra Korda, 20 years ago, top European tennis player. Edgar Davids, top footballer, instantly recognizable by the kind of goggle type glasses he wore. Now, lots of people have tested positive and they've come up with some great excuses. They've eaten meat that's come from cattle that's been fed steroids. Well, you can read the others. Toothpaste, eye drops, eating veal. Some good excuses there. But scientists have found that if you're taking certain dietary supplements and you're exercising a lot, you can get a positive nandrolone test. That is surprising. Watch this space. Anyway, back to testosterone. Now, testosterone has got an interesting isomer. It's called epitestosterone. The 2 isomers differ because that carbon's what we call a chiral carbon. It's got 4 different groups attached to it, which gives rise to optical isomers, because the OH and the H can be in different places. Otherwise, everything's the same. There are other chiral centers, they're not changed. It's just that one. And that's what epimers are. Very specific stereoisomers. Now, normally, people have got about a 1-to-1 ratio of testosterone to epitestosterone. But if you are taking testosterone supplements, your ratio goes above 1-to-1. And that can be picked up in drug tests. Of course, people tried getting around this by actually taking extra synthetic epitestosterone. There are some sneaky people out there. The most famous person in recent years to be caught abusing testosterone was Floyd Landis. He was Lance Armstrong's successor as a top American cyclist. It is said that his T to E ratio is 11-to-1. I've never seen that published. That's a story that came out. He would have won the Tour de France, but he lost it. He got disqualified. Still with steroids, gestrinone had been made synthetically, and it was used as a legitimate medicine, as a contraceptive. An enterprising chemist thought, if I reduce that CC triple bonds, and that's an alkyne type group, which you may or may not forget, by adding 2 hydrogens to each carbon, adding 4 hydrogen atoms, that's 2 H2s. This is catalytic hydrogenation, folks. You all, I think, know about this. You make an alkyl group. You've now got another of these tertiary alcohol containing steroids. That should be anabolic. And guess what it was? It's also an androgen. It did lots of things to people who took it. Bulked their muscles, made them stronger, gave them faster recovery times, you name it. It became very popular, people took it. Marion Jones, 20 years ago, top American sprinter. Look at that, won Olympics, won 5 medals. It caught up for 7 years later. Records showed that she'd been taking it, rather than actual drug tests. She had to admit it, she lost those medals. Why do people take it? Well, there's a receptor in the body called the androgen receptor that binds testosterone similar molecules. These are these crystalline structures that show how testosterone fits into a receptor, how hydrogenated testosterone fits in, and how THG fits in. THG fits in better. It doesn't form hydrogen bonds, it doesn't form covalent bonds, it forms hydrogen bonds. That enables it to bind most strongly to the receptor, and that has its effect on the body. It's stronger androgenic effects, and your body will get all those benefits. It was only found by accident. An athletics coach was watching at a meet, and he spotted another coach dump a syringe in a trash can. So he pulled that syringe out and sent it on to the drug testers. This is the guy who made THG, Patrick Arnold. He did a degree in chemistry. You can do anything for your chemist. He was also a bodybuilder, and he made various illegal drugs. Oh, he did 3 months inside for that as well. Here's a guy who promoted this, a man called Victor Comte. He got time inside. Here's the top man, Don Catherine. For many years, he ran the Olympic Drug Testing Agency. He was the man who found THG in the sample in that syringe. They got the sample on June 5th, 2003. Within a month, They cracked what the molecule was, its structure. They then found a way of making it to check it, and they came up with the test. And they found that 4 people in the American Athletics Championships were using it. That's 6 weeks' work for a very special chemist. Chemistry isn't normally that exciting and that rewarding, but who knows? And they published it. This is the research paper about it that told people how to test it. Caroline Hatton was Don Catlin's number 2. She worked in drug testing for 20 odd years, and then she gave it up to do what she'd always really wanted to do, and that's to write children's books. You can do anything if you're a chemist. And this is